Okay, a little bit about me. I work as a principal engineer, take care of entire data platform at OlaCabs. OlaCabs is one of the largest ride-hailing company in India. So you can compare it to Uber of US. And I'm an open source contributor and a PMC and committer at Apache Falcon. So that's introduction about me. So we'll quickly go through about OlaCabs because most of the folks are from US. So our company is the largest ride-hailing company in India, presence in multiple countries. We have covered Bangladesh, some Asian countries, and now we have launched in Australia as well. Over 100 cities in India. We have a huge supply of cars. These are the different business lines of cars. We have Prime, Mini, Micro, Share. Share is like Uber Pool. We have Auto. Auto is a kind of a three-wheeler, which is a very cheap transportation in India. Most of the folks use because the traffic is very high in India and it's easy to get auto. And we have luxury, of course. And finally, we have rentals, where you can pre-book your car a day before for like 4 hours or 8 hour ride, right? So that's about the business line we manage. Recently, we have expanded across multiple business lines. If you look at it, we have Ola Money, Foodpanda as the recent acquisition, what we have done. We have Ridella and Ola Store as well. So can't reveal the numbers, so I'll just say millions of rides a day. And finally, we have launched a differentiator with Uber, right? So Ola Play is what we have launched a year ago, which is very similar to Ola's in-flight car entertainment. So if you if you take a flight, you see a entertainment system in front of you where you can control it, right? Similarly, if you get into a Ola cab, it welcomes you. It's a contextual base. It knows about the customer. It knows about your choices, of course, based on your consent. And it knows your user history. Let's say you have played a track in your last ride. It would ask you, would you like to continue to play your ride from now? So those kind of things it does out of the box, right? So you get into the car, your mobile automatically connects to the OlaCab's Wi-Fi. And the best part is now you can control your volume, AC, everything with your mobile or the entertainment system. So this is one differentiator. Let's move on. So the problem what we are trying to solve at Ola is since the business has grown tremendously, we have grown organically day on day, and developers are sometimes lazy and paranoid, so they log everything, right? So we needed some system. By the way, this is something different to your normal analysis of data. This is more about your unstructured logs, what the developers log using a log4j kind of system or SLF4 based system, right? So that data needs to be analyzed. So since the developers are paranoid, they dump everything. They don't want to take a risk, and we have a lot of compliance and legal requirement where we need to look back and debug at each and every point level where the exact lat long of a cab location, what happened at that time, what microservices the cab actually, the service actually invoked. So for that reason, we need to log a lot, and there are a lot of microservices. If you look at here, we have like 1,000 plus apps, right? So by the way, these are not containers. The apps itself, we have around 1,000 microservices, and you can multiply with hundreds of containers, right? So this is the scale. Volume, so it's 2 months ago, we were around like 250 terabyte per day, just the unstructured logs. 4 million, and max is gone up to 15 million. Some of our allocation services logs a lot, and there is a map-based service which needs to look at the maps and allocate cabs, so that also logs like very high. Of course, the users are not the analysts, typical analysts. Here, the users are actually developers and QA. We did look at some proprietary log management system, but that was very expensive, right? So you might have heard about Sumo Logic or Splunk or some other log management system. So what we had before, so first look at the challenges. So we need to ship billions of logs. 30 Gbps is the like one-way link to Kafka. We were managing biggest Elastic cluster and Kafka cluster. So the old system was built on top of Greylog and Elasticsearch nodes. It's a typical open source based log analytics system where you feed in distributed logs into a system, then you run a query on top of it. And the ES system behind the scene indexes all your tokens, and like your queries become really, really fast. The compliance requirement wanted us to search logs for like a larger duration, maybe like 30 days or 15 days, but with ES we cannot store, so the cluster has to be ever running. I cannot have a like cold store and then dump out of the box into hot store and allow developers for the log searching. So we were thinking, can we move eager indexing of logs to lazy searching of logs? That means, can we get away with ES, which does indexing whether you like it or not, over a day, night, and just bring in like whenever a developer or a QA invokes a query, you just need to search at that moment and shut down the cluster because you don't care. Developers in India, we work at a different time zone, night. You don't see a lot of users working, so there is no point running a cluster, right? Similarly, the log volume at night, you see, you do not see a lot of bookings, so the log volumes also come down. As I said, we were growing like 10% with a growth rate. This was one of the most expensive service. It became slowly. So this is what we had before. So when initially we started off, we thought that okay, it's very cool, just 2K per month, and it has got a nice UI with Kibana. So everybody were happy, like developers were very happy searching logs from distributed services. But over a year, it became like unmanageable, right? So 2K to like over 400K per month dollars. That's like too much. And since we were expanding across the globe, Australia and everywhere, the logs was like increasing day on day. So we thought that we need to look at some other solution which might not be like very user friendly to developers or QA, but at the same time solves the debugging and the compliance requirement. So with this solution, what we have done is from the estimated cost of 640K, we have brought down to 170K per month. It's like a very good saving if anybody is building a system for log analytics. So overall, this is the architecture. On your right side, what you see is the old way of analyzing logs. Blacklight is something which is homegrown tool on top of Golang. So there are other open source solutions. What they do is they move data from Kafka to your stores like S3 or Azure Data Lake, right? So similarly, Blacklight was built because we wanted to get away with JVMs. We had a lot of open file issues problem. Managing that in a Java-based environment was very difficult. So we had to code a different one. Though Secor is open source by Pinterest, so we thought that we'll build our own. So this can handle like at really scale Blacklight. Of course, the data goes to Elasticsearch, then we index store, and developers come in query, and the queries are really quick. But the problem with ES is, we were, by the way, we are fully on Amazon AWS, so it's a cloud-based solution, and all our nodes on ES were like kind of on-demand nodes. So we had to pay a decent price for it, right? So what we thought can we get away with these two pieces? Because if you look at the cost factor, right, this is how it was. So the cost pressure came from the top management, so we had to look at each and every component and see where all we can reduce the cost. The first one is, of course, the Kafka. We were on EBS nodes, EBS volumes. We got away with that and just moved to ephemeral. We made Blacklight as auto-scaling, as and when your log volume increases and it decreases in the night, the service downscales, thus saves the cost. And finally, the data lands in AWS S3. And Presto, on demand, we just bring up the Presto cluster. We auto-scale Presto cluster, and the best part is it's fully on the spot nodes, and you pay. So we are on Singapore region, so we pay around 1/8 or 1/6 of the cost. And the fun part is, in last 1 year, we haven't lost a single spot instance, right? So Of course, MSTR is the BI tool, so we just used MSTR to build a nice UI, not as good as Kibana, but where developers can just feed in the requirement and the query the logs.
So in your Elasticsearch, right, were you all your logs were also stored, or you just had the reverse index?
We had a reverse index mostly, but the reverse index itself was so much because the way the different applications were logging, it was just growing day in and day out. It was mostly reverse index. Yeah.
Okay, so you did not have stored fields.
Yeah, right. You are right. Okay. So going with the Presto cluster setting, right? So we wanted to the motivation is to reduce cost, right? So 3 things. One is, can I get cheap nodes on the cloud? Yes, spot instances are the answer. Can I aggressively auto upscale and downscale? Yes, Kubol has nicely solved that problem for us. And third one is, can I optimize Presto for unstructured logging and searching, right? So we did some tuning along with Kubol. We'll talk about it, right? So these are some of the things. So one of our cluster is around we have 2 clusters and they have different SLA guarantees, because for the compliance reason, a developer can come and want to analyze logs for say last 30 days and which can run into petabytes. So there is no strict SLA guarantee on that, right? It is just analyzing a whole data lake for whatever reason. So we have a different Presto cluster, which is a Presto cluster 1. And most of the time during deployment, we follow something like n+1 deployment and see what's happening, right? We want to do some kind of distributed tail of logs. So we provided a cluster which guarantees a decent SLA. Of course, it's not as good as ES. It's around 2 minutes. So what it does is, it has a pre-warmed cluster available so that we cannot waste time on bringing a cluster up during the outages or whatever the issue when the deployments are going on. And there are some restrictions, like you can search logs up to only 2 hours, recent 2 hours. You cannot just go and say what happened last month, right? So these are some of the restrictions which we had. And of course, we have few more clusters because of the same nodes what we have come across in the past talk on Presto, right? So your coordinator is not HA. So for that reason, we had to bring up multiple clusters. So we are fully on C4-8x large because log search is very similar to your map-only job. It doesn't do any join, any kind of group by operation. It's plain pass-through of your logs. It's pure map-only kind of job. Some of the things what we have done with Kubol is, with AWS allowing us with per second billing, Kubol also came up with a per second billing for QCUH computation, right? So let's say I run a query for just 10 minutes, cluster comes up, run, I shut down. Before that, we had to pay for at least 1 hour. Now I just pay for 10 minutes. We did some setting for aggressive downscaling where we don't wait for the cluster to remain alive forever, it just downscales. We have templatized a Presto query so that nobody just runs any kind of ad hoc query. So we just allow, this is the query which you can run, you just need to feed in your dates. Of course, the query performs well because the data is partitioned based on date and hour, right? So you feed in the date and hour and it just goes and brings only that data without touching any of your data lake's data. We use Kubol Rubik's cache as well, which is a good, decent cache built on top of Presto. So what it does, so most of the logging use cases you search, then you want to do another search on a similar data set with a different search query. So I need not go to a remote S3 store. What we do is, we just cache the data in Rubik's and the next query is very fast. And finally, we allow regex search, and there is one more patch which Kubol has worked with us is on handling corrupt GZ files. As you know that logs are flowing from different microservices. It's possible that some of the corrupt files can land in your store. So one corrupt file can actually bring down your query job, right? It just throws an Hive exception saying that cannot parse that data and so the job fails. So we gracefully handle the corrupt file and just go ahead further. One thing to note here is regex are very expensive on Presto or any other system, right? It's a very high CPU intensive query. So what we do is we do not recommend developers or QA to run very complex regex queries. So let's take an example of a query. Somebody wants to look for a particular booking ID of a cab along with some error condition. So what we do is we recommend them not running a AND regex query where you can use parenthesis grouping and run a AND kind of regex queries. We ask them to just run a query based on the booking ID. The assumption here is, of course, you will not have same booking ID available in millions of rows, right? It will be like very few, like max it runs into thousands of rows. So then we bring the data back to the client and we do client-side filtering with the second condition. So that's what we do. If you do the same thing on the server side, it becomes very expensive because every log line it tries to run that regex expression and the things becomes very slow. We could handle like a lot of messages. SLS were like decent, of course not comparable to ES, but the amount of cost we were saving and based on the organic growth, what we are seeing, it was pretty good. Now it allows users to query logs up to 30 days. Even with storing reverse indexes, 30 days was too much of data. And the problem with reverse index for some of our application, as you asked, is we do not know the tokens in advance. It could be anything. People just dump in huge JSON logs. Sometimes it runs into MBs of data, right? So that is one reason, like sometimes we had to like just dump in the entire log and ask it to like go index the entire stuff. So this is the thing what we achieved. Of course, the cost saving was very high. Now it allows the developers to query up to 30 days. Of course, we move data in S3 from warm store to then cold store, and if anybody wants the data, there is a separate API which we have provided on top of it, which brings data from AWS cold store back to kind of warm store and allows us to query from here. Now it has a decent security and audit model. With the default Kibana, it was like very plain. Now since it's a custom Presto based engine, we had tuned our JDBC query, integrated with our LDAP server, the corp IT server, and we know the user roles and we know exactly what that user is allowed to run on what table. Improved efficiency. We were trying to open source the Blacklight, which is a Golang based thing. Reduced cost of logging of $260K per month, right? It's a huge saving. And finally, no need to manage ES and Greylog. So we were running hundreds of on-demand ES and Greylog servers, got away fully with it. Now we don't have any server at all. The logs just lands in S3, and on-demand we just bring up the cluster. It scales up aggressively from like 3 nodes to like 100 nodes based on your query and number of concurrent queries, and we just shut down once the query is done, right? So I think that's it, done.
Any questions?
Did you get a raise?
Sorry?
You saved $260,000 a month.
Yeah. We got a trip to attend this conference, sponsored trip.
So the interface lets you choose between Elasticsearch and, or it doesn't even?
No, it doesn't even.
The interface doesn't.
Yeah. So you see a small cost on the ES and Greylog. That's for some of the critical service where the developers are really paranoid and don't trust the system. So they wanted to continue with ES. And there the log is very structured. Reverse indexing works very well on that, and log volume doesn't run into like terabytes per hour. So some of our system logs, like probably we did some analysis and it was logging more than the NASA CERN data. I don't know what's getting logged there. So that's how it was growing.
Have you implemented your own scale down solution, or you're depending on Kuble's scale
No,
down?
it's fully on Kubole, yeah.
Has it
So-
been working like really aggressive or?
So for us, it really worked well. I have a live demo. I thought of showing that. So we have a live Presto-based cluster where you can see. So each worker node is doing a work of around 1 million log lines per second. That's great for me, right? 1 million log lines per second, and up to like 250 Mbps per second of data is getting processed by one single worker. And upscaling and downscaling, we never had any problem with that. Of course, we had to tune something because if the connector what we have used is a Hive-based Presto connector, right? So by default, that comes up with a 5-minute kind of to scan the metadata of partitions and all. We had to bring that down like much lower so that as soon as the data arrives, it's available for querying. So those kind of tuning we had to do.
Another question related to Elasticsearch. So do you index entire message, log message,
Yeah,
or
for most cases we had to index because it's a highly unstructured message and we don't know what needs to be indexed in advance, unlike a catalog based ES system where I know in advance that this is what I'm interested in.
So your clusters are actually coming up and down, and you said you're using Rubik's caching. So
Yeah.
how does that work?
So the assumption here is the developer who has run one query, his subsequent query will be on the same data set. There were two Presto 1 and Presto 2 cluster, right? One was on a recent with a strict SLA, so it's meant for that. So I query for last 1 hour, my next query immediately with a different booking ID would be on the same data set. So it's for that. So once he works for like 15 minutes or half an hour, the cluster just goes down and the cache also expires.
Hi, so 2 questions about regular expressions. Presto actually has 2 regex engines,
Yeah.
and some are better than, depending on the regular expression, one will be faster than the other. I'm curious if you tried switching from one to the other.
So we tried, I'm not aware of the other regex engine, this is the just default, the UDF is,
So the function of
regex like is the function, the UDF is what we use.
Yeah, so the functions don't change, but there's a config option for the server that tells it whether to use RE2J or Joni. I don't remember which one's the default, but
Okay.
for your regular expressions, it's possible the other one could be faster.
Okay,
Or some
cool.
could be faster and some could be slower.
That's a good suggestion, we'll try out definitely.
The other question, so you mentioned that doing the regex on the server was slower. So Presto today evaluates expressions left to right and should do short circuiting. So if you said booking ID equals X and regex something else,
Right.
it shouldn't run the regex if the booking ID matches. If that's not true, we should look into it. It's a bug.
Okay, yeah, thank you. So I just wanted to show the recent query which ran like some time back. I had opened it, right? So this is how a query template looks like, very simply. So we don't allow user to write this query. It's a templatized query. They just feed in their search string and things come out of the box. So he is here, he's trying to analyze an application by name Mappy Java City Taxi. And this is the message he is interested in. And this is a templatized query which we have formed behind the scene. So of course, this is the crux because this guy filters out the stuff nicely. And if you look at it, so it has scanned 226 GB of compressed GC data in around, say, 1.97 minutes. And the number of workers, if you look at, analyze the worker logs, so the cluster was like not fully scaled because it was the first or second query. So with 15 workers, it was able to do this work. So it's pretty decent. And these are like mostly the default settings. We have not played with like optimizing it much further. We were just happy with what we were getting out of the box, right? So that's the good part about Presto. Unlike Hive where you need to tune hundreds of parameters. So one thing what we wanted to show was like compare the Presto benchmarking numbers with Hive on LLAP benchmark number. But again, as somebody asked, right, LLAP requires you to cache the remote S3 data locally. So that won't be like very cost effective. So, but still we want to do the one kind of benchmarking. One problem which we mostly face is sometimes a single user bombards with like tens of queries and it might affect the analysis for the other user, which the kind of user-based isolation on CPU is what we are trying to solve. What we did was, we did something like a memory-based isolation, ensure that one guy doesn't take up the whole cluster or whatever it is. So that's how we are trying to do the isolation as of today, just a memory-based isolation. But what we would eventually need is a kind of a CPU-based isolation wherein I can cap the CPU for per user. Yeah. Okay, thank you.
Great. Thank you again, especially on short
Yeah.
notice. That was great.
Thanks for coming.